All right, what's up, guys? This is Ryan from Elevate Cyber, back with another video for you guys on what you need to know for OSCP. This time we are covering GDB. We covered GCC and some C exploits, how to handle them in a previous video. Right now, the natural progression for that is covering GDB, which is the GNU debugger. This is a command line utility that is pre-installed in almost every distro of Linux you'll encounter out there. For a lot of the boxes that you exploit, especially in OSCP, you'll find that they do have GDB. So if you're doing any kind of buffer overflow exploit kind of stuff, or even just running local exploits and you want to see what's going on with the registers and stuff like that, then you can easily do that in Linux if they have GDB installed. So the way you're going to use this most of the time, I've found, is just simply GDB and the name of the binary file, right? So if you are dealing with C, for example, there'll be a C file, which is like the source code, and that will compile into a binary. That binary is the file that you want to pass into GDB, not the C source code. You want the actual binary, okay? And this can work with binaries that are generated from any programming language, pretty much. As long as it's in the binary format, you can use it with GDB. So once you run this command here, you'll see this little you'll see all your lines starting with GDB in parentheses. That just denotes that you are operating inside GDB. So once you have it opened up in there, you can actually supply it with R and then any argument you want to run. So R is a command within GDB that is short for run. And so you can run, for example, you can run Python inline commands where you can actually start fuzzing stuff, and you can view the registers and everything straight from GDB. You don't even have to leave GDB to do all this stuff. That's the great part. So specifically, the reason I'm including this is Python is, there's different ways to do this, but Python is the way that I have most commonly used this functionality within the context of OSCP and the CTFs that I've done. Basically, you can give it R for run, and then you can you can do this in backticks as well. But in this example, I have it with, you can do it $ and parentheses, and then that's where you have your Python code, right? You can do -C to tell it we're going to do this inline, and you can have it print like 400 A's or whatever fuzzing techniques you want to use. You can do that straight. You don't even have to leave GDB in order to do that. That's how you would do it. All right. Now you can look for different registers as well. In this example here, I'm looking for the ESP register. I want to see what's going on, like where it is in memory, what's the value at that address. And I can set breakpoints too within GDB, and I can look at what the values of the registers are at whatever different breakpoints, right? But if I wanted to, for example, look for the ESP register, which is the stack pointer, I can do that in GDB by supplying it with this. Let's break this command down really quick. The X that we see here is for examine, right? We have R for run, X for examine, and then you tell it how many bytes you want to examine. In this case, the 100 is for 100 bytes, and we want it to denote hexadecimal. That's why we have that there. And then we want to prepend this $ to let it know that we're looking for a register. And we can tell it whatever register, right? Could be EIP, EAX, whatever. In this case, the stack pointer is what we're looking for. That's why we have $ESP. And a little extra bonus that I'll give you guys is that you can actually use this tool here from GitHub called PETA. It's an extension of GDB, and I'll show you what that looks like here. It's a really cool tool that I've used a few times here. This is nothing that you necessarily need to have or anything, but a little way to, because GDB can look pretty pretty old and pretty bare bones. Let's just put it that way, right? This will give you a nice, prettier view, and it will give you some additional functionality as well. Like one thing that I think is super cool is you can actually do that pattern offset stuff and generate your own patterns and everything. You know how you'd normally have to use the Metasploit pattern offset and what's the other one? The pattern create. You can actually use that, I believe, within the context of PETA. So, you know, here breaks down a bunch of the commands that you have available to you, and there's so much more that you can find online. I think I found a cheat sheet earlier. I don't think I have that up right now, but you can Google search that. This is how you install it, and I included that here as well. Just grab it from GitHub and put it in your home directory or whatever, and initialize it, and you're pretty much up and running at that point with this. And this is kind of what it looks like here. Some screenshots. Looks super nice. You have it like color coordinated and everything. Normally you wouldn't, like if you just ran GDB without PETA, it would be really black and white and it wouldn't be nearly as clean looking. So see, look, you can use that pattern stuff here I was talking about and do it completely, very simply within here. And just gives you a better view, some more functionality. Just overall improves GDB, so I'd recommend it. I'll just showcase how that works really quick. I have a program, a basic Hello World program called helloworld.c that I created here. All I need to do is type GDB. Since I've already done this installation here, I've already done this on my system. Now it's as simple as just running this command up here, GDB, and the binary, hello world. Like so, and it automatically opens it up in PETA, GDB PETA. So there you go. Very simple installation there. And now anytime I use GDB, I'm using it within PETA. And there's all these help commands that you can run to find out what options you have. And then you can even do like, what was it, show help or help show, and it'll show you, yeah, all this stuff, and you can get really granular on stuff. Just within here, you can find a lot of information. Of course, you can Google as well. So this is just a bonus. You don't have to use this. You can definitely get by with using just GDB. And if you want to see how to do that, watch my Narnia series, because we're using GDB without PETA in that one, and we're able to do everything we need to do. Now I'll give you a little bit more hands-on practical information on how to do this. This is just the quick and dirty what you need to know for OSCP. So hopefully this video was of help to you guys. If so, be sure to smash the subscribe as well as the like button to help get that message out there, and I will see you guys in the next video.